everyone, hope you're staying safe. In this video we're going to see 10 more questions on strength of materials. So let's get started.
And before we start, I would really appreciate it if you could smash that like button, drop me a comment and share this free program with anyone who might need it.
The first question is, what is modulus of elasticity? So most of the time we tend to mistake modulus of elasticity to Young's modulus, which is noted by E. But the common definition for modulus of elasticity is it is equal to stress by strain. Just that. We have subdivisions like Young's modulus, shear modulus, bulk modulus, etc. So let us see what is Young's modulus. This is the ratio of longitudinal stress by strain, and shear modulus, it is shear stress by shear strain, and shear modulus, it also goes by the name modulus of rigidity, and shear modulus, it is denoted by either C or N or G. You can keep compressed natural gas in mind to remember this. And Young's modulus, it is denoted by E. Next is bulk modulus. So bulk modulus is change in stress by volumetric strain, and it is denoted by K. Going to the next question, what is resilience? Giving you the definition, the strain energy stored in a body due to external loading is known as resilience. So if we take a stress strain curve of say a mild steel rod, so it will be something like this. So here we can see this point is called as our elastic limit. Till my elastic limit, if I remove my load, my material will be able to come back to its original shape. So how will this material come back to its original shape? It is because of the strain energy that it stores inside. So the strain energy stored in a body due to the external loading on the material is known as resilience. I hope you were able to understand what is resilience. Going to the next question, what is proof resilience? So proof resilience means just the maximum amount of resilience that can be stored. So the maximum amount of strain energy that can be stored in a body up to the elastic limit, because after the elastic limit, the material, it will not come back to its original shape. Up to the elastic limit is defined as proof resilience. So I have another modulus here along with the shear modulus and bulk modulus and Young's modulus. We have modulus called modulus of resilience. It is equal to just this proof resilience divided by volume of the body. Go to the next question, what is Poisson's ratio? So it's a simple question. It is nothing but lateral strain divided by longitudinal strain. Another thing you have to keep in mind for Poisson's ratio is the maximum value of Poisson's ratio can be up to 0.5 only. So this question has been asked in so many exams, so many competitive exams. So this is very important. Keep this in mind. Next is, what is the Poisson's ratio of concrete? So we being civil engineers, this is very important. For concrete, it is 0.1 to 0.2. So another things to keep in mind is for cork, it is 0, and rubber, it is 0.5. So I told you in the previous slide that the maximum amount of Poisson's ratio can be 0.5 only. So we can understand that rubber has the highest amount of Poisson's ratio. So how is this Poisson's ratio related to Young's modulus? So we have like 4 relations here. The relation between Young's modulus and Poisson's ratio, and the relationship between again Young's modulus, this is bulk modulus, and Poisson's ratio, and other relations. So something I have to insist here is it is very important. All these 4 formulas are very important. They are like one of the most important formulas in strength of materials. So make sure you know all these 4 formulas in your fingertips. It will be useful in many questions, and one such example is our next question. So if the Young's modulus of elasticity, so they have given E, is twice the modulus of rigidity. So modulus of rigidity means it is G is equal to 2 times G, because they have told twice. So it is equal to 2G. Then what is the Poisson's ratio? So they are asking what is the Poisson's ratio. It is also denoted as nu. It was also denoted like this. So the relationship, if I am not wrong, is E is equal to 2G into 1 plus nu. I like to keep this in mind because it is very easy to remember 2G, 3G, etc. So we know that E is equal to 2G. So 2G is equal to 2G into 1 plus nu. So let me cancel these both. So this becomes 1 is equal to 1 plus nu. 1 gets cancelled. This means nu is equal to 0. So my answer is Poisson's ratio, it is equal to 0. N number of questions can be asked from these 4 relationships. So make sure you remember all these things perfectly in your mind. Going to the next question, what is the limit of proportionality and what does it depend on? So limit of proportionality, we have already seen in the previous video in the stress strain curve that for a curve at the starting, let me for example let us take mild steel bar. So firstly it will be linear, both stress and strain, then it will reach the limit of proportionality or the proportionality limit. What happens here is, from this point stress will not be proportional to strain. So this is only called as limit of proportionality, and then comes the elastic point. I mean elastic limit. So elastic limit is, we have seen in the previous video, the elastic limit. If the load on the material is removed, it will come back to its original shape. That is only called as elastic limit. And then we'll have our upper yield point, lower yield point, the lag, and the ultimate stress and the, ultimate stress and failure. So now coming again to proportionality limit. So we know that stress is directly proportional to strain until the proportionality limit. This is equal to Young's modulus into strain. So it is quite clear that the limit of proportionality, it is dependent on this Young's modulus. So the question here is really, what does this Young's modulus depend on? So Young's modulus, it depends on the type of material only. We know that it is different for steel. For steel it is 2 into 10 power 5 Newton per mm square, and for concrete it is lesser than that. So for concrete it is 5000 times root FCK. So it depends on the type of material, what this Young's modulus. So as a result, limit of proportionality also depends on the material only. Going to the next question, the number of elastic constants in isotropic material obeying Hooke's law is what? So they have given isotropic material, that is for Hooke's law. We assume that the material is isotropic. So Hooke's law is valid here. So they have already told it obeys Hooke's law. E is equal to 2g into 1 plus nu. So we can see that it is dependent on g and nu. So they are two elastic constants. So the answer to the question, for an isotropic material, the answer is 2. Whereas for other type of materials like anisotropic, it is 21, and for orthotropic, it is 9. So what is the difference between all these three types of materials? So isotropic materials have same properties in all the directions. If we come to orthotropic, we'll take just the x, y and z directions only, and in these three directions the properties won't be the same. Coming to anisotropic material, there isn't any specific direction coordinates here. In all the directions the property of the material will be different. So go to the next question and the last question, what is modular ratio? So we have already seen modular ratio in the RCC lectures. In case you haven't watched them, I have linked to it in the description box below. And in RCC we have seen that this modular ratio plays an important role in one type of method. What is that? I'll give you an answer. Is it limit state method or working stress method? Yes, you're right. It plays an important role in working stress method. We have seen it in detail in RCC. Therefore, I'm not going to linger much on that topic. Telling you what is modular ratio, it is simply the modulus of elasticity of one material, of material 1 to material 2. The most commonly used modular ratio is the one which we use for design purposes in working stress method. This is equal to modulus of elasticity of steel to that of concrete, denoted by M. This is your answer. I often get confused whether it is C upon S or S upon C. So something I kept in mind is S for Srinagar, which is the capital of Kashmir, which is like in the northern part of India. So since it is north, I have kept in mind that S comes at the top, and C, my hometown, starts with C. Therefore, I kept that in mind. You can keep anything in mind, just make sure you don't confuse them. And that's it. We come to the end of this video. Thank you so much for watching, guys. I hope you found this useful. If you did, please do comment below and give this video a like. And even if you found that this wasn't helpful, I'm really open to negative reviews. Please let me know how I can improve myself. Thank you so much for watching. I'll see you in the next video. Bye bye and take care and stay safe.